Hi everyone, welcome back. In today's video, we'll dive into color spaces and various types of color spaces such as HSV, BGR, Grayscale, and so on and so forth. Thereafter, we'll move into drawing of objects like circle, rectangle, lines with OpenCV, and finally, we'll learn how to write text with OpenCV from our system. If you found this useful, hit the like button, subscribe, and share. The first thing we need to do is to create a file, and the file is going to be named colorspace.py. And what next? We import CV2, that's the library we'll be using, and thereafter image is equals to CV2. It's basically to read our image. So we're going to read that garden, and the garden is, the name of the file is garden.jpg, jpg. Exactly. So I'm going to basically visualize this image for you to see first, that we've been able to capture the image, and thereafter we'll move next to how to convert from one color space to another color space. So I'm going to say that cv2.imshow, do not forget we use imshow to actually visualize our image. So I'll say image, and here will be img, and say that cv2.weight key 0 and cv2.destroy all windows. That's it. So let's see our image. Okay, this is a beautiful garden, and that's the original image. So what we need to do next is to actually convert from the channel we have here to, from the color space we have here to another color space. But one thing I want you to note is that the color space which we actually get from cv2.imread is BGR. So BGR is a channel which we actually get, and the channel of the BGR channel has basically three values. Values are blue, green, and red. Something with RGB. RGB has red, green, and blue. But when it comes to Grayscale, Grayscale has only one channel, and that's why Grayscale is the fastest when it comes to object detection. It has just one channel, sorry, just one value. So first of all, in order not to confuse you, we're going to take it step by step. The first one we're going to work with is to convert from BGR to RGB. So like I said, BGR is what we get automatically from CV2imread when we actually visualize, when we actually process an image. So I'll say that img RGB is equals to cv2.cvt color. And that's how we convert from one color space to another. So I'm going to convert. What do I want to convert? Obviously, it's the image. So I'll say image and cv2.uppercase color BGR, the default color space, to RGB. And let's visualize that. So that's cv2.imshow of our RGB image, and that'll be img RGB, and that's it. So let's visualize and see. Exactly, so we've gotten it. So this is our RGB and this is our BGR. The BGR here has the original color and everything here, while the RGB has actually changed the color. You could see here blue has been changed to red, red has been changed to blue, and if you could look at this place, it's kind of reddish in nature, while here is bluish in nature. And this also, the sky here has actually changed. Here we actually had light blue, or sky blue rather, and here we're having something that is somewhat of orange, or you could call it yellow, as the case may be. I think this is orange, yes. So that is it for color space to convert from one color space to another. So but you may be wondering, why do we actually need to convert from BGR to RGB? Why not just use it the way it is? No, we can't use it, because in different technologies we actually have to change the color space in order to get an efficient model performance. A use case of this is actually when we are working with a media pipe. There is a library called media pipe that enables us to use its solution. One of the solutions there, it's called the first mesh. So with first mesh, you can actually convert, you can actually detect one's ear, face, mouth, lips, all those parts. But before you do that, you need to convert the image from BGR to RGB for it to process effectively and efficiently. Otherwise, it's not going to give you a good or a high performing result. So what I'm going to say is that that is a use case. We use it in first mesh, that's face landmark, And the next one we're going to talk about is the grayscale. Now, grayscale has only one value in its channel. It has a channel of one value and is actually recognized as the fastest, especially when using object detection. So I've already told you the use case. It's basically used for object detection. That is grayscale for you. And we're going to say that img underscore gray is equal to cv2.cvt, and that image, our original image, and set as cv2 color BGR again to gray. And that's it. So let's actually visualize our gray. cv2.imshow of gray image img underscore gray. Let's visualize that and look at it. That's the gray image. So the gray image looks more like the 1905 or 1854 when we had the black and white television. So that's it. And for the gray image, I told you for object detection. And the next one I'm going to explain to you is called HSV. So I say img HSV is equals to cv2.cvt color and our image over here, and I'm going to say cv2.color from BGR to HSV. So let's visualize HSV. But before then, let me comment this too so that I know they won't be showing any longer. So cv2.imshow of my HSV image HSV. Let's visualize it. Yo, this is what we get. It looks somehow, it doesn't really look appealing like this one looks. So this is mostly used in applications like where you're trying to detect different colors. It could be you're detecting objects with different colors. For example, an apple, you could detect an apple that has maybe a yellow color, apple with red color, an object that has different colors. So HSV actually works perfectly with that. And that's it. And what I want you to do is to go through the documentation over here. There are over 150 color spaces like I mentioned earlier on. I want you to explore few of this and just experiment through with them. The last part of this session is to draw objects like lines, rectangles, and circles, and also write text on our screen or perhaps the image we're going to use. And the image happens to be a TV, so you can come over to freepik.com here and search for TV, and this is the TV I'm going to use. I already downloaded it. So let's go back to our Visual Studio Code, and this is the TV over here, and that's it. So we are going to use this TV to experiment the drawing and writing of text. So I'll say drawing, create a file called drawing.py. What we need to do is to import CV2. We import CV2, and the next thing we want to do is to actually read our image. So I'll say TV is equals to cv2.imread, and that is our tv.jpg, and that's it. So what next do we do? Well, let's try and print the properties of this image, which is the shape of the image, so we can actually get the height and the width of this image. So what next we want to do is to visualize the image. So I'll say cv2.imshow. I'm going to show my TV and TV here. cv2.width key and 0, and that's it. So let's visualize our image. So this is it. This is a TV. So all the things you're going to do with the drawing of objects, the line, the rectangle, the circle, putting of text is going to be within this range and not beyond this range. So everything we'll do will be within this range. So let's get started with that. Firstly, I want you to look at this. This is the height. We've gotten the height, which is 1,333, and the width, which is 2,000. And of course, our channel is 3. That's from BGR. This is the value we have from BGR channel, and that's it. So without further ado, let's move to line. First of all, let's see how we draw a line in OpenCV. So we say cv2.line, the line property, and what we need to do about line is, where do we want to draw this line? We want to draw the line on our TV. So we put TV over here, and the next thing we need to do is the coordinates. where do we actually want to draw this line? A line actually has a starting point and an ending point, but the starting point is not just by declaring one value. You declare the x value and the y value. So you can actually see the x value as the horizontal and the y value as a vertical. So let's try and see, when we visualize the image, we know that we have a space before the white label TV. Yes, I'm going to explain that to you again. But what we need to do is, like, let's try and see how we can put 200 to our x value, and perhaps, let me say, our y value should be 400. Take note that the y value simply means the space we want to give before we start drawing the line. This is like the initial. So where do we start? That is it. So here is going to be where do we end, and that is the next coordinate. So it's still going to be our x value and y value. So if you want it to be a straight line, it definitely means that your height will be the same. So I'm going to say my height will be the same, but here I'm going to use 600. That's for the x value, and for my y value I'll still repeat 400. And what do you need to do next? The next thing you need to do is to declare the color which you want. So I'll say my color will be 2550 and 0, and I'm going to use a width. I want the width of this should be 5, and that's it. So let's try and see how we can visualize it. So cv2.image show of our line, and over here I'm going to say line, and that's it. So let's visualize our line. Oh, you see the line? This is the line, but the line touched the border of this TV. It touched the frame of the TV. I don't want anything to be on the frame. I want it to be inside the white label aspect of the TV. I don't even want it to go beyond this range. So like I explained to you, the 200 you see here is actually the distance from year to year, and the 400 you see here is the distance from year to year, and the ending part, the 600 you see here, simply means the total distance from year to year plus year to year. So it definitely means from year to year is 600, and to make it be on a straight line, we still repeat the height, which is 400, which gives us this. If, for instance, I had declared 700 here, this would have been from here to perhaps somewhere here. Yes, let's do 700 so that you understand what I mean by the distance between the height. So that's it. I need to kill and close this, and you've seen exactly this is how the line goes. So that's how I just want it to be on a straight line. So I'll leave it 400, and I'll try to extend the initial x value to 300, so it can actually pass. It can actually be a yes. That's how it is. So you can actually play along with the font, the weight of it. So if you say 10, and that should work well. Let me close this and run 10, and that's it. So that's the thickness of the line. The next thing we want to talk about is the rectangle. The rectangle is somewhat similar to the line. So I'll say my rectangle is equal to cv2, the rectangle, and this is the rectangle we're going to use. Where do we want to draw the rectangle? Obviously on our TV, and the coordinates, also the starting point and the ending point of the rectangle. I don't want to use 300, because if I use 300, it's definitely going to clash with the line. So I'd say to start from maybe 350, and the height should be above the height of the line. So that could be 500. And also here, I'm going to say, where does it end? Well, if I wanted to, and I am going to state, let me see, I wanted to extend further. I want the width to extend. Since it's a rectangle, so I want it to extend. So I'm going to say here will be 600, and here should extend to maybe 800 or even 900. And what's the thickness? Sorry, not just thickness, first the color. So I'm going to say 255 255. Yeah, let me change the color, and the thickness is going to be, let me see, let me use 10, and over here I'll say cv2.image show and rectangle and rectangle. Exactly. So let's see how rectangular it looks. Beautiful. So we got a pink color. Is this a pink or purple? Looks like purple, but it's pink. Anyway, so we've gotten our rectangle. This is it. You can play along. If you actually want this rectangle to be the width of it to increase from here to somewhere here, I think there's something we can actually do to make that. What do you think we should do? Just think about it. Pause this video and think of the value we can actually change to make that work. So what value? If you actually got this 600, then you're right, because this is, let me try and visualize it and explain to you. Now, this is the starting point, which is the 350, and this is 600. So if you wanted to extend further, since our total width is 2000 over here, we can actually make it 1500 and see where it ends. So let's try and see 1500. Please feel free to play along with these values. You can do anything with it, and it doesn't break your system, neither is it gonna affect your system. So that's it. So that is rectangle. But since we have circle, I'm not going to use this because I still want space. I still want space. Obviously, I need space. So I'm going to use here, and I'm trying to explain this step by step such that you understand every pattern here and all the underlying codes and concepts. So the next thing I'm going to work on is circle. So I'll say my circle is equal to CV2 dot circle. And where do I want to draw the circle? Obviously, I want to draw it on our TV. And now what's going to be the coordinates? Now a circle doesn't have a starting point and an ending point. You just have one coordinate, just one coordinate. It doesn't have two coordinates like the line and the rectangle. So I'm going to say that since the other one started by 350, I want it to be a little bit closer to the center, or perhaps the center. So I would say 600, and my height should be to start from somewhere. If the initial height of this was 500, that means my circle should be somewhere maybe 600. Or let me see, let me use 500. I don't want to use both values to be the same. And for circle, what do I want to do next? The next thing I want to do is the color of my circle. So the color of my circle is gonna be 00255, and the width of, sorry, I'm supposed to pass in here how large or how small I want my circle to be. So if I want my circle to be small, I'm gonna say my circle is gonna be 80. Let me just do 100, and let's see. And the thickness of the circle is going to be 10. Let me use 10. And so what I'm going to do next is to say that cv2.imshow of my circle, and circle over here and circle over here, and that's it. So let's run this. Oh, this is our circle, but it's not even close to the center. So you could move it to the center. Let's try and see how we can actually move it to the center by using 1000. So let's see. And that's it. So we can make it here. You can play along with this. And the last thing we want to do is to actually put a text on this. And to do that, you're going to say that cv2 dot put text here. And what we need to do is, where do we want to put the text? We want to put the text on our TV, still in the white screen. So the next thing we're going to do, relax, it's not the coordinates, but the text you want to put. So I'm going to say, you are welcome to Offiong Bassey's channel, comma, kindly, no, not just kindly, please, I beg of you, please subscribe. That's it. So now we've actually imputed the text we want. The next thing we want to do is actually our coordinates. Where do you want this text to be? So I want it to be a little bit close to the bottom. So since our height is 1333, let me see, I want it to be at 800. Am I correct? No, I'm not correct. That should be the x value. So I want the x value should be somewhere 500, not too far. It shouldn't get closer to the center, and the height should be 800 apart. So that's it. And the next thing I'm going to pass to is the font style. So I'll say cv2 dot, we have different fonts here, so but I like this hash simplex, and that's it. So what's going to be my font size? This is going to be how big you want the size to be, and the font size I'm going to say is, let me try and use 2. Let's see. And what next is going to be our color. So I'll say 25500, and the next one is the weight. If you've been working with font weight, then you understand this. So I'm going to say, let me try and use 10. Let's just see how it comes out. We can always fine tune it to what we want. So this is it. You are welcome to Offiong Bassey. However, it exceeded this region. So there are two things we can actually do with this. Since we are okay with the starting point, what we need to do next is that we can reduce the font size, or we reduce the font weight. So here is actually the font size. I'll make it 1, and here's the font weight is too thick. I'll make it 2. Let's see how it looks. Oh, it looks nice. It almost looks as if it went to the center, though it's not center. If you want to do a deep dive on this, but it's to visualization, it looks like center, and I don't like where it is, so I'm going to reduce it. I'm going to take the height. I'll say my height should be 1000. Please bring it a little bit down. And that's it. This looks beautiful. I wish I actually made this line to be on top here and actually made this to be on top here, so everything would just be centralized. But this is not centralized, so that's it. Now let me explain to you the use cases of this in different applications. This line, you could use this line to draw just a line if you want to do some sort of experiment. And I've mostly used rectangle and circles. I'm not going to lie to you. I've used rectangles in contours. In one of our videos that is coming up, I'll show you contours where we detect objects like maybe a bird. We detect different birds, or we detect different dogs. Then we'll draw a rectangle. You could see these in object detection. So this is basically using contours where you see where you actually see a green rectangle surrounding an object, surrounding another object, surrounding another object. So that is where it is being used. And for the circle, when we are working with face mesh, like face landmark, so the CV2 circle is when you're working on face mesh, when you're working with face mesh. If you're working on a face mesh application using media pipe and you actually want to draw dotted lines, or maybe just dots on the face, that is where circle is used. And for the put text, obviously when you're working on an application and you want to write the text on it, that's it. So that's how it is, and that's all for this video. I'm going to push this code to the repository. You can pull it from there. You can clone, you can do whatever you want and make modifications. Hi, I'm really excited that you've been able to complete this video. That's actually amazing. So in our next video, we'll explore different mechanisms and techniques of blurring, and you will be able to learn and master blurring in just 15 minutes from our next video. So what are you waiting for? Please, if you found this useful, hit the like button, subscribe, and share. See you in the next video.